Good day. Welcome to Mathematics class grade 9 students. Again, this is Sir Harold at your service. To start with, let us first talk about the safety protocols against COVID-19. First, always wash your hands. Second, wear face mask and face shield at all times. And third, always observe physical distancing. Through these safety protocols, we could fight against COVID-19. Alright, before we begin our discussion today, let me first ask you, how are you today? I hope you are all doing fine, and I want to share a quote for all of you today. It says, "Believe you can, and you're halfway there." It's just a matter of believing in ourselves, and through that belief, through that positive energy, we could go places. We could go to our destination. Also, I would like to share that it takes a lot of courage to push through hard times. Never give up. Good things are coming your way. Alright, let's begin. Welcome to Quarter 1, Week 1. Our topic this week is illustrations of quadratic equations. Alright, before we begin our discussion today, let us first know our objectives for today. First, identify and illustrate quadratic equations. Second, write a quadratic equation in standard form and identify its coefficients. And third, value accumulated knowledge as means of new understanding in applying the concepts to real-life context. Alright, let's begin. Beginning with our objective number 1. Identify and illustrate quadratic equations. To start with, let us begin with a short review by asking you the question, which of the following equations are linear and not linear? So during your grade 8 years, you have discussed all about linear equations. So let us see if you still remember those concepts. Starting with number 1. C is equal to 12n minus 5. Is it linear or not linear? Of course, it is linear because the highest degree in the equation is 1. Let's have number 2. 9 minus 4x is equal to 15. Is it linear or not linear? The correct answer is linear, since again, the highest degree is 1. Next in line, we have x squared minus 5x plus 3 is equal to 0. Is it linear or not linear? The correct answer is not linear, because based on the equation, the highest degree that you could see is 2. Next, number 4. 6p minus q is equal to 10. Is it linear or not linear? The correct answer is, of course, linear. And finally, 9r squared minus 25 is equal to 0. Is it linear or not linear? The correct answer is, of course, not linear because we have their squared as the highest exponent. Now, if we are going to group our equations between linear equations and not linear equations, we are going to come up with this table. We have here linear with c is equal to 12 and minus 5, 9 minus 4x equals 15, and 6p minus q is equal to 10. While on our not linear side, we have x squared minus 5x plus 3 equals 0. And 9r squared minus 25 is equal to 0. Now, let us try to define what are linear equations. Of course, these are first degree equations in which the highest exponent is 1. Now, I want you to look on the not linear side and observe the equations that we put there. The question is, what now do we call those equations in the given that are considered not linear? The answer is quadratic equations. So, we are going to call the following equations on the not linear side as quadratic equations. Alright, so let us now try to define quadratic equations. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a should not be equal to 0. Why? Because if a would be equal to 0, the entire quadratic equations will be cancelled. Since there would be no value or coefficient for a, there would be no value also for the quadratic term, and it would just be simply a linear equation. That is why in quadratic equations, a should not be equal to 0. Now, in the equation, ax squared is the quadratic term, bx is the linear term, and c is the constant term. Again, this is the standard form. Ax squared plus bx plus c is equal to 0. Okay, let's proceed. Okay, now let's try to analyze more on some illustrations of quadratic equations. Let us go back to the given on our previous activity and let us try to chunks each of the context there. So here is the table. We have here quadratic equations with our previous given x squared minus 5x plus 3 equals 0 and 9r squared minus 25 is equal to 0. We say on our definition that ax squared is the quadratic term, bx is the linear term, and c is the constant term. Therefore, we are going to have the coefficients a, b, and c. A will be coming from the quadratic term, b will be coming from the linear term, and c will be from the constant term. So let's try to get each of the terms in our first given x squared minus 5x plus 3 is equal to 0. So for the first equation, our quadratic term is x squared. Since we have here x squared on the first one having the highest degree, which is 2. Next, our linear term is negative 5x and our constant term is 3. So if we're going to remove the literal coefficients and just to get the numerical coefficients, the value of our a with respect to quadratic term x squared is of course will be 1. Since automatic, we have here a constant 1 as the numerical coefficient. For our b, it will be negative 5. And for our c, it is 3. Okay, so we just completed the first table. Now, let's have the second quadratic equations. 9r squared minus 25 is equal to 0. Let us have the quadratic term. That would be 9r squared. Good. For the linear term, the answer is 0. Why? Because if you could see here on our quadratic equation, there is no linear term. If there is no linear term, we're just going to have there 0. And for our constant term, that is negative 25. Now, let us have the coefficients. Of course, our a will be 9, b is of course 0, and c is negative 25. And that is how we chunk the quadratic term, linear term, and constant term into the quadratic equations. Okay, let's proceed. Okay, so we just finished the first leg of our discussion. So now let's have exercise number 1. Fact or bluff. Write fact if the equation is quadratic and bluff if the equation is not quadratic. State your reasons for your answer. Okay, let's start. Exercise number 1, fact or bluff. Item number 1. 2x squared plus 5x plus 3 is equal to 0. I will give you 10 seconds to answer. But if 10 seconds is not enough for you, you may pause the video, continue answering, then if you're done, play it again, and then check your answer. Okay, 10 seconds up. Let's now check your answer. The correct answer is fact. Because the highest exponent in the equation is 2. And that is what we have on our previous definition of quadratic equations. Did you get it right? Okay, very good. Fact or bluff? Item number 2. 4x minus 3 is equal to 5. Your 10 seconds start now. Alright, time's up. The correct answer is bluff. Because the highest exponent in the equation is 1. And therefore, it is not quadratic but rather a linear equation. Okay, very good. Fact or bluff, item number 3. 3 over 4m squared minus 9m minus 8 is equal to 0. Your 10 seconds start now. Okay, time's up. The correct answer is fact. Because the highest exponent in the equation is 2. Okay, very good. Okay, so you are now capable of identifying and illustrating quadratic equations. So let's now move to objective number 2. Write a quadratic equation in standard form and identify its coefficients. Let's begin. As we say, quadratic equation's standard form is ax squared plus bx plus c is equal to 0. In the equation, again, ax squared is the quadratic term, bx is the linear term, and c is the constant term. However, sometimes a quadratic equation doesn't look like that. There are equations that are occasionally called hidden quadratic equations. And that's what we're going to discuss next. We are going to put those hidden quadratic equations into standard form. Okay, let's start. Let us now move to transforming quadratic equations into standard form. Example number 1. We have here as our guide standard form ax squared plus bx plus c is equal to 0. Okay, we have x squared is equal to 3x minus 1. We all know that this one is a quadratic equation. However, this is not in its standard form. So in order for us to put this into its standard form, we have to move all the terms to the left side of the equation. In that way, we could have x squared minus 3x plus 1 is equal to 0. We use the properties of equality in order for us to move those terms on the right to the left side of the equation. So, that would be, for our A, that would be 1, B is negative 3, and C is 1. Okay. Now, let us have example number 2. We have here 2 times the quantity of w squared minus 2w is equal to 5. We have to put this into standard form by expanding the terms on the left, then move 5 to the left side of the equation. So in order for us to do that, we have here 2 times w squared is 2w squared. And 2 times negative 2w is negative 4w is equal to 5. Now, we had already successfully expanded the terms on the left. The next thing that we're going to do is to move 5 to the left side of the equation. We are going to use addition property of equality. We are going to add negative 5 to 5 and then to the other side as well in order for us to cancel this 5, therefore giving us 2w squared minus 4w minus 5 is equal to 0. Now, let us try to determine the coefficients. Our A is 2, our B is negative 4, and our C is negative 5. Okay. Let us now have example number 3. We have z times the quantity of z minus 1 is equal to 3. What we're going to do is expand the terms on the left, then move 3 to the left side of the equation. Expanding it would give us z times z is equal to z squared. Z times negative 1 is equal to negative z is equal to 3. Okay, so we have already expanded it. The next thing that we're going to do is move 3 to the left side of the equation. So it would be z squared minus z minus 3 is equal to 0. Let us identify the coefficients. The value of A is 1, our B is negative 1, and our C is negative 3. Okay. Now let us have example number 4. We have here 5 plus 1 over x minus 1 over x squared is equal to 0. As you could see, we have here fractional form. So what we're going to do is multiply the whole equation to x squared. In order for us to do that, we're going to have here x squared times the quantity of 5 plus 1 over x minus 1 over x squared is equal to 0. So if we're going to multiply it, we're going to have here x squared times 5 is 5x squared. X squared times 1 over x would be x squared over x. X squared times 1 over x squared would be x squared over x squared is equal to 0. As you could see, we have here terms that is factorable or cancelable for that matter. Would be the x squared to the x. So x squared divided by x would be simply x. Next, we have x squared and x squared. So x squared divided by x squared would be 1. So therefore, our resulting quadratic equation will be 5x squared plus x minus 1 is equal to 0. And for the value of the coefficients, our A is 5, B is 1, and C is negative 1. Alright. Okay, so since we're now done with the second half of our discussion, let's now have our exercise number 2. Transform it. Transform each equation in standard form of quadratic equation, then identify the values of A, B, and C. Let's start. Okay, for this exercise, you are going to transform each of the equation into its standard form and identify the values of A, B, and C. Starting up with item number 1. X squared plus 3 is equal to 2x times the quantity of 6x plus 4. So I would be giving you 30 seconds to answer this item. But if 30 seconds is not enough for you, you may pause the video, continue answering, play it again, and then check your answers. Your timer starts now. Alright, time's up. It's now time to check your answers. Now, with respect to our given, what we're going to do first is expand the terms on the right, then move those on the left to the right side of the equation, then combine like terms. Okay, let's do that one by one. So, expanding the terms on the right, this one, 2x times the quantity of 6x plus 4, it would be 2x times 6x is 12x squared, while 2x times 4 is 8x. Now, the next thing that we're going to do is move those on the left side to the right side of the equation. So, it would be 0 is equal to 12x squared minus, okay, so put x squared on the other side using addition property of equality. So it would be negative x squared plus 8x here. And then also using addition property of equality, we're going to add negative 3 to each side of the equation. So these 3 would be cancelled. And and then we have here minus 3. Next that we're going to do is to combine like terms. So we have here 12x squared minus x squared, and that is 11x squared. So plus 8x minus 3. So rewriting it would be 11x squared plus 8x minus 3 is equal to 0. So since it is already now on standard form, we could now get the value of a, b, and c. So our a is 11, b is 8, and our c is negative 3. Did you get it right? Very good. Okay, let's proceed to the next one. Moving on to item number 2. We have our given negative 3x times the quantity of x plus 5 is equal to 0. Your timer starts now. Alright, time's up. It's now time to check your answers. Okay, so with respect to our given, what we're going to do is expand the terms on the left, then move all the terms on the left to the right side of the equation. How's that possible? First, we're going to expand. Negative 3x times x is equal to negative 3x squared. Negative 3x times 5 is negative 15x is equal to 0. Now, if you're wondering why we have to move all these terms on the left to the right side, because it's better if our quadratic term is not negative. So in order for this not to be negative, let's try to move all these terms to the right. Okay, so that would be 0 is equal to 3x squared plus 15x. So again, we had used addition property of equality. We add positive 3x squared plus 15x to this side in order for us to cancel it and move it to the other side. Therefore, we have now 3x squared plus 15x is equal to 0. And the values of our a, b, and c are 3, 15, and 0 because we do not have constant term. Okay, did you get it right? Very good. Now it's time for us to summarize quadratic equations. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. Next, in the equation, ax squared is the quadratic term, bx is the linear term, and c is the constant term. Finally, you need to manipulate and expand some terms in some cases in order for us to get the standard form of quadratic equation. Alright! Now, it's time to test your understanding. Okay, for the assessment of your learning, let's try this. Determine which among the given equations are quadratic. I will give you 30 seconds to answer the 3. Your timer starts now. Okay, time's up. It's now time to check your answers. Our given number 1 is x squared plus x minus 3 is equal to 0. Now, since we have here the leading term, which is the quadratic term, having 2 as the exponent, therefore it is quadratic. Next, number 2, 5x minus 3 is equal to 0. As you could see, we do not have any term having the degree of 2. Therefore, it is not quadratic. Number 3, 24x plus 81 is equal to x squared. Although this is not in standard form, but if you are going to change this into standard form by using addition property of equality to move 24x plus 81 to the right side of the equation, it would then be a quadratic. How many scores did you get? Did you get 3 out of 3? I know you did. Very good. Okay, another activity. Try this. Number 2. Transform the equation in standard form of quadratic equation, then identify the values of a, b, and c. The given is 5 minus x plus x times the quantity of 2x minus 3 is equal to 12. Again, I will be giving you 30 seconds to answer this. Your timer starts now. Alright, time's up. It's now time to check your answers. For our given, the first thing that we're going to do is expand the terms on the parentheses. So it will be x times 2x is 2x squared. X times negative 3 is negative 3x. So we have 5 minus x plus 2x squared minus 3x is equal to 12. Next step is move the term on the right side to the left side. So it will be 5 minus x plus 2x squared minus 3x minus 12. We have used addition property of equality in order to move 12 from right side to the left side. And finally, just combine like terms. So we have 2x squared here, and then negative x minus 3x is negative 4x. 5 minus 12 is negative 7. So our final quadratic equation is 2x squared minus 4x minus 7 is equal to 0. Our a is 2, our b is negative 4, and our c is negative 7. Did you get that right? Okay, very good. Okay, now for the attainment of our final objective, which is to relate the context to real-life problems and real-life applications, let's have quadratic equation in real life. Quadratic equations are actually used in everyday life, as when calculating areas, determining a product's profit, or formulating the speed of an object. But more than that, in terms of degree of polynomials, we could actually extract a moral lesson and a virtue to quadratic equations. How? Quadratic equations has a degree of 2, and therefore, it is the leading term superseding the linear term. In other words, Applying it to virtue-based context, in our life, we should always obey the one who has the highest degree over us, like our parents, our boss, or even our God in heaven. Indeed, it is a lesson of obedience. Those who are above us, those who have higher degree over us, those who have authority over us, we must obey them. And that's how obedience works in relation to quadratic equations. Isn't that cool? Alright. Okay, it's now time for our math quote of the day. Failure doesn't mean the game is over. It means try again with experience. You know what, students, in dealing mathematics, it is important for you not to give up. Just try and try. Because as we say, when you fail, it's not the end of the road. It just means you can try again. And you will try again with experience. And as you try and try, of course, you would gain much expertise and you would master the context and the concepts, and eventually you would be a success. Okay. Alright, and that concludes our discussion for this week. Goodbye, grade 9 students, and God bless. Again, this has been your Sir Harold, your grade 9 mathematics teacher. God bless. Enjoy the rest of the day and see you on our next video. Bye!
Don't forget to like, subscribe, and share!